All right, welcome everyone. Think of this as your pre-mission briefing. Before you get into the real nitty-gritty of the readings, we're going to gear you up with what I like to call the Data Detective's Toolkit. This whole session is really about the why behind it all, giving you the big picture on the key techniques you're about to learn for doing some really solid social science research. So let's just jump right in with the core challenge, the central mystery we're always trying to solve. How on earth do you measure something as squishy and complex as, say, burnout, or what it feels like to be marginalized? The things we really want to study are often pretty abstract, and the raw data we collect can be, well, it can be a mess. This is the case we need to crack. Okay, so in any investigation, our first suspect is always the outlier. What are they? They're those unique data points, the ones that are way, way higher or way, way lower than everything else. They just don't fit the pattern. And if we're not careful, they can completely distort the truth, leading us down the wrong path to the wrong conclusions. Now, here's why they're so dangerous. One bad apple, one outlier can spoil the whole bunch. It creates this domino effect. A single outlier makes all your data look more spread out than it actually is, which is what we call increasing the variance. That, in turn, messes up all our other calculations. The main thing to remember is that one sketchy piece of evidence can totally compromise our entire investigation. So, what do we do about these troublemakers? Well, like any good detective, we've got a specialized toolkit. We're going to focus on two main techniques for handling outliers. And the real key, the trick, is knowing which tool to pull out based on the kind of data you're looking at. Here are our two go-to tools. On one side, we have the 3 sigma rule. You use this when your data looks like a nice, classic bell curve. But if your data is all lopsided and skewed, you need a different tool, the 1.5 IQR rule. You see, the shape of the data itself tells us which tool we need to grab. Let's look at that first one, the 3 sigma rule. The idea here is actually pretty simple. Basically, for a normal bell curve, almost everything, like 99.7% of your data, should fall within a certain range. So all we do is calculate that range, and anything that falls outside of it gets flagged as a suspicious outlier. Don't get bogged down in the formulas yet, just focus on the logic. And wow, you can really see the impact here. On the left, you've got data on people's height. It's mostly a bell curve, but you see those few stray bars on the very ends? Now, look at the right. After we use the 3 sigma rule to remove just 8 of those outliers, the picture gets so much clearer, so much cleaner. It's a small fix that makes our evidence way more trustworthy. But, what if our data isn't a perfect bell curve? What if it's messy? Well, that's when we bring in our second tool, the 1.5 IQR rule. This one is clever because it doesn't use the average, which can get totally thrown off by outliers. Instead, it looks at the middle 50% of the data to figure out what's normal. It's built for the kind of skewed, real-world data we see all the time. And just look at the difference this makes. On the left, we've got some BMI data. It's a total mess, right? Heavily skewed with some crazy high values. But after we apply the 1.5 IQR rule, look at the chart on the right. It's so much more balanced and normal looking. We've basically tamed this wild data and made it something we can actually rely on. Okay, so we figured out how to clean up the evidence we find at the scene. But what about when we have to create the evidence ourselves? This gets us to our next big case. How do we take a really complex, abstract idea and turn it into hard data we can actually measure? The tools we use for this are called scales and indexes. Here's the big idea. Instead of trying to capture something like burnout with just one single question, we combine a whole bunch of related questions to get at it from different angles. It's how we turn a fuzzy idea into a solid number we can analyze. But you can't just throw a bunch of random questions together and call it a day. Building a good scale takes some real detective work. You have to start with a strong theory about what you're even trying to measure. You have to make sure every question is measured on the same scale, that they're all pointing in the same direction, from low to high, and that you have a real 0 point. It's a super thoughtful process. So that leads us to a huge question. We've gone through all this work to build a new measurement tool, but how do we know if it's any good? How can we be sure that all those questions we put together are actually measuring the same core idea? We need some kind of quality control check. And that's where this thing called Cronbach's alpha comes in. Just think of it as a reliability score. It gives us a number between 0 and 1, and it tells us how well our questions all hang together as a group. Basically, it's checking to see if all our clues are pointing to the same suspect.
And generally, we're looking for a score of 0.70 or higher.
So for our new marginalization scale, we run the test and we get a 0.75. Hey, not bad. That's definitely in the acceptable range. But a good detective never settles for just acceptable, right? The real question is, can we make it even better? And funny enough, the analysis itself gives us our next clue. The computer points to one specific question in our scale and basically says, hey, if you got rid of this item, your overall reliability score might actually go up. It seems like that one question might be clouding the issue. Now, I know exactly what you're thinking. Wait a second. If we were just going to remove it, why did you make us put it in there in the first place? And well, as the book humorously says, it builds character. Seriously, though, this is what research is all about. It's a process. You build something, you test it, you refine it, you test it again. It's just part of the job. And look, here's the payoff. We followed the clue, we removed that one item, and we reran the test. Our new Cronbox Alpha jumps up to 0.79. See that? We went from acceptable to good. Our detective work paid off. We now have a much stronger, more reliable tool. And so this is our final product. This is what it all leads to. We've successfully taken 5 different questions and combined them into a single, powerful, and reliable score for marginalization. We have officially measured the unmeasurable, and this new variable is ready to go. So, what's the big takeaway from all this? It's actually pretty simple. Good research starts with good data. Period. Cleaning up outliers and building scales that you can trust, these aren't just tedious rules you have to follow. They are absolutely essential detective skills for finding the truth. So I'll leave you with this question to chew on as you start your readings. Now that you've had a peek inside the detective's toolkit, what complex, seemingly unmeasurable part of our social world are you going to go out and investigate?